Today we are going to do section 1.6 on page 68, which is the last section of this review chapter, but it's also the most important one. Now before we start, please look at this and see if you already know this, okay? Because if you already know it, then there is no point for you to do so. Now, can you do this stuff in your sleep? Does it all look 100% familiar to you? And it's not a problem at all. If the answer is yes, please skip this section. Now, if you only know 99% of it, then let's finish this section, okay? Because the importance of this section is that the entire rest of this algebra course, well, it actually is the beginning, being that we're still only in review, that the entire rest of the course, the entire algebra course and everything after it depends on this stuff, okay, in this section. I mean, it makes the difference of whether you enjoy algebra or you have no clue what's going on. That's how important this is. So please make absolutely sure that you know how to do this type of problem. Okay, so now that we've said that, let's look at what are we talking about? We are talking about division, okay? Division tends to be a huge hang-up for algebra students because of it's slightly confusing sometimes, and there are a lot of rules, so it's hard to remember. However, as a result, people tend to just skip it, but it's very important to understand division exactly. Okay, now once you understand it, then everything comes very naturally, and you don't have to necessarily find it, well, you won't be finding it difficult if you understand it, but then that's true of all math. Now, to remember what we're talking about, let's look at the properties that I showed you earlier, okay, some kind of a summary. What we need to know in this section is various rules that if you don't remember it, okay, see all these things? Do any of them look familiar to you? I mean, do they all look familiar? Because if not, please study them very carefully to make sure that they make sense. And I'm going to talk about it here as well. Now first, this is the factoring principle, right? If you have the same thing multiplied by other different stuff, then you can factor it out like this. Okay, now in terms of multiplication, when you have something multiplied by a fraction, you multiply the number to the numerator, because anything like this is the same as having a 1 underneath. The number a is the same as a over 1. So in fraction multiplication, we always do numerator times numerator and denominator times denominator. And that's why if you have just a number with no denominator, that means the denominator is 1, and therefore you multiply accordingly, and that's why that is the case. Now, the next one is when you have a fraction divided by some number, that's the same as simply put that number next, multiply it by the denominator. Okay, that is a rule. Well, that's fine. But what if you would write it there differently? See, this is the longer line, and that's the division line. That is the fraction line. Okay, they look the same, but the longer one is the one who decides. Now, but to explain what that means is that when you are dividing by a fraction, how to divide by a fraction? To divide by a fraction, you inverse and multiply. Okay, that is probably the most important rule to remember in algebra or pre-algebra is to divide by a fraction, you invert and multiply. So you flip this around, so C gets on top and multiply by A, and then B stays at the bottom. Now, let's explain this stuff a little bit. Now, if you have A over B divided by C over C, right? This fraction is over this part. How do you do that? That's the same as to divide by C. What is C? C is the same as C over 1. So as a result, to divide is to invert and multiply. Okay, so you invert this, it becomes 1 over C, and then you multiply things together, top by top and bottom by bottom, and you get this particular answer. And that's how we got this thing to come out. Now the next equation that we just mentioned, this one, I've explained it here. If you have a long division line, means divide by the fraction B over C. See, A divided by B over C. To divide by a fraction, you invert and multiply. And which means that to divide by B over C is the same as multiply multiplying by c over b. You know, you flip it around, and then you multiply it according to this rule. When you have a number multiplied by a fraction, you multiply the number to the numerator, and there's the denominator stays put. And that's the principle we're going by, okay? And that's how you get this. The next step is what if we have two fractions added together? To add fractions, then what we do is have the common denominator, which we do by the principle is that we multiply each fraction by the let's see. Okay, b. See, here's the other d, so we multiply them together on top and bottom. So then a and b now becomes ab times d over d. Well, d over d is just 1, okay? So then that nothing's different. This is the same thing. Similarly, c over d is, we multiply by b over b. And then which is just 1, so we haven't changed anything. But when you add them up, because now they have the same denominator, then we can add up the fractions. So we just add up on top, and that equals to that. And which is why this equation ends up equal to that equation. And that is how you normally do fractions in lower grades. This is just written in a symbolic form so that you can see what's going on. Now, the next thing is even more important, is how do you divide by a fraction? You have a fraction divided by another fraction. So what you do is, this is the division line, so okay, so we can write it down as a over b divided by c over d. To divide, you invert and multiply. This is the second thing, okay, dividing by. So you flip the c over d around, it becomes d over c, and then you multiply accordingly, and that equals to ad over bc, and that's how this particular fraction is done, okay? And that is written in this thing. And please write down whatever you see here that you're not familiar with in your cheat sheet. That way you can refer to it anytime, okay? This part is extremely important both for this section and for the and for any future stuff, the future math you're going to study from this point on. All right, so now that we have done the review for the review, okay, or a preview for the review, now let's look at section 1.6. Okay, first we need to simplify some rational expression. Okay, let's look at example 1. In this section, please do all the examples as part of your homework as well, including to the ones I showed you earlier on the page. Now, the example 1, we have some kind of rational expression, and we're supposed to simplify it. Now, the way to simplify something like that, yeah, actually, how about, yeah. Anyway, so how do you simplify this? Well, it might or might not simplify at all, okay? But if it does, what we're going to do is factor it and see if there's anything in common. So x squared minus 9 factors, that's the perfect square factoring, okay? And the perfect square factors in the previous section that we did, how does the perfect square factor? That is a squared minus b squared is factors as a plus b times a minus b. This is extremely important and should be memorized. Okay, this is one of the few things you need to memorize. It's just more convenient that way. So we have x squared. In example 1, we have x squared minus 9. Okay, that would become following this plan. Then x squared minus 9 factors into x plus 3 and x minus 3, plus and minus, where because x times x is x squared, and then 3 times 3 is 9, and everything else in between, there's a plus 3x and a minus 3x, and they cancel themselves out. All right, so what's on the bottom? On the bottom, there is something called x squared plus 4x plus 3. And this one, we have to factor it out as, well, you multiply this thing, okay? And then we have x here and x here. And then you have only 3, so everything's positive. So everything's pretty good, okay? And, well, everything better be positive, basically. And that you check it. See, 1 times 3 becomes 3. X times x is x squared, okay? And then in here, 1 times x is x. And then outside, x times 3 is that's the terms with just x in it. You will have 1 times x and 3 times x, and that's 4 times x. So that comes out. But the point how the factoring is from the previous section is extremely important for this section. If you haven't gotten factoring down completely or need some help, be sure to refer to the previous section as to how to factor either one of these things or anything else that you see in this section. All right. So once you have done the factoring, then the job is simple. See, we have x plus 3 in both the numerator and the denominator. So you cancel that out, and what's left is your answer. And that is example 1. So please do example 1, redo it as part of your homework. Just just look at the problem, don't look at the explanation, and see if you can come up with it yourself. Next, let's what's the next example? Okay, example 2. Example 2, you have a pile of stuff, and nothing's different here. What we do is, again, we're going to factor, and then we're going to find whatever is in common on top and bottom, and then we're going to cancel it. And whatever's left, that is your answer. Now you say, well, what if there's nothing in common on top and bottom? If in that case there is no, that's it, okay? And what you got is what you have. There is nothing else to do about it. Okay, so please do example 2, and then let's look at example 3. Now example 3 looks long and complicated, right? We have a division symbol right here, and then you have 2 fractions that both look like they need to be factored, and that's what you're going to do. But before that, remember, what does it mean to divide by a fraction? See, here's a fraction dividing by another fraction. To divide means to invert and multiply. The second thing, okay? The thing that you're dividing by, you invert it and then multiply it through, and that's how you do it. So to do example 3, the first thing we do before we factor anything at all is to invert and multiply the second term. Just flip it upside down, and then we have, let's look at the next page. I'm now on page 71, where we have done the invert and multiply, and so which means now we're ready to factor. Okay, so the invert and multiply has been done, okay, and then we're going to do the factoring. So factor the first one, and the bottom, which is a difference of squares. Okay, use this trick right here, and then the other stuff is, and then the other one is a perfect square, which is fine. We'll write it down there. And then we'll do cancellation. We can start canceling right here. Don't have to copy it all down. It's a waste of time. Now, right here, you see the x plus 1 is canceled out with the x plus 1 over there. So there is one x plus 1 term left on top. Okay, I will write that down. So we have x plus 1. There's 1 left because the other one got canceled out with a 1 on the bottom. Okay, and then so next we have, what else do we have? X plus 2 is also canceled out. So there's nothing, no more x plus 2 left, and that's it. So what's left on top is there's a 2x plus 3 that's left. Okay, 2x plus 3. And then what's left on the bottom is the x plus 1 got canceled out on the bottom. X minus 1, nobody bothered it, so he's still there, right? And then x plus 2 got canceled out. And then x minus 2, nobody bothered him, so x minus 2 is still here. And that then becomes your answer to this example, which is what? Example 3. So please redo this yourself as part of your homework. Now, next, let's look at example 4. Now, example 4, we have to add rational expressions. And especially when it has x and y in the denominator, which looks confusing if you're not used to it. But it makes no difference at all if it has x and y in the denominator. Now, where's our fraction addition? Right here, okay? If you have a over b plus c over d, it doesn't matter what a, b, c, d's are. It could be a number, it could be x, y, w, omega from the Greek, or pi, or anything you can think of, or an orange. It all works the same way. If you have a over b plus c over d, here's the rule we go by, okay? We do this thing, and then which end up being this. So we'll go from here to here. We'll multiply the denominator together, okay? And then we take a times the d, a times the denominator in the other side, and c times b, the denominator from the first one, and that is your answer. So as a result, if you look at example 4, then the answer to example 4 would be, we're following that rule, okay? So the denominator is b and d, that's what's on the bottom, so which is x, y, and the numerator is the first one, okay, which is 5, and times y. So we follow the rule, is 5 times y, and the second one is 6. C stands for 6, right? And 6 times x, because b is x in this case. So it would be 6 times x. So plus 6 times x, and that is your answer. Okay, let's look at the next page and confirm that we're right. And so we have 6x plus 5y over xy, and that's the answer. Yeah, these two, doesn't matter how you write it. Okay, it's an addition. You can do it however you want. Addition changes. 1 plus 2 is the same as 2 plus 1. So that is example 4. Please redo it as part of your homework. Now next, subtraction of fractions. What happens when you subtract fractions? The subtraction is not different than addition in this sense, that any subtraction is the same as adding a negative value. That is, for example, to add plus c is, or another way is, let's see, do I have a space here? So if we have, let's say it's a subtraction, right? So we have a over b minus c over d, that is the same as a over b plus negative c over d. Okay, so then, and then we apply this rule anyway. That is, if a over b is minus c over d, then you end up changing the sign here. Why don't I just write that down? Okay, that equals to ad minus bc over bd. So yeah, so the sign simply changes right along, and otherwise everything is the same. So to do that, then we're going to follow the same rules as always, except this time the denominator has more than one thing. Okay, you have x plus 2 squared, and then you have x plus 2 and x minus 2. So what we're going to do is make it into the common denominator by multiplying, and what do we have? The common denominator is, in this case, okay, we have x plus 2, okay, in here, and then there's 2 of them in the first term, squared, but there's only 1 in the other term. Okay, this is x. So what we need to do is find the common denominator, which is in the first term, we have to multiply it by x minus 2. And the second term, we have to multiply by x plus 2. That way, everybody will have x plus 2 squared, okay, 2 of those, and 1 x minus 2. So everybody has just the exact same amount of stuff, okay, after we're doing this multiplication. Now, once we do multiplication, then we have to do, so now everything has the common denominator, and then we have to do the subtraction. Now, let me clean off the board to explain this better. So we're doing example 5 on page 72, but before that, let's do a simpler version to see what's going on. Let's say we have a problem of 6 over a squared and then 2 over ab, okay, where a here we stand for x plus 2, and then b here stands for x minus 2. Now, how would you do this problem right here, just by looking at it? Never mind example 5 for a second. Now, to do this problem, then you have to find the common denominator, right? And the way we do that would be we need to multiply it by this thing to be in common. Then we have the whole thing should be a squared b. Okay, we'll multiply it by b, so which means we'll multiply it by b on top too. It becomes 6b on top. Okay, and this together will become, if you cancel the b out, that will become a 6 over a squared, same as that thing. Similarly, we're going to write down this is 2 over, we need it to be a squared b, so we write that as, we'll multiply it by a down, top and bottom, so then the ab, and so that becomes a squared b, and that's how we do it. So the answer to this simplified version would be 6b minus 2a, okay, divided by a squared b. that would be how we do this. And we're doing this based on the principle right here. Okay, this is what we're doing is, in this case we have to multiply by we just have to multiply by the b, and then everything kind of works out. But it's the same idea as this, okay, or this one. It's being that we're doing a subtraction. The subtraction sign just follows right along. Now, however, what does that mean if the problem is slightly more complicated, as in this case where we said a equal to x plus 2, and now b stands for x minus 2. The idea is still the same. Okay, we'll multiply it by one of them will multiply it by x minus 2. Okay, and the other one by x plus 2, and then we end up with something like this, right? We have 6 of x minus 2, and then minus 2 times, okay, b is x minus 2, and then 2 times x plus 2, and then all over the denominator, which is a bunch of stuff. Now the denominator is there, but the question, remember how to do this, okay? Now I'll write down the denominator, which is end up being x plus 2 squared times x minus 2. Now the question is, how do you do this subtraction? Now this is the part that you have to watch out very carefully. Remember how to multiply stuff out? You have to take this one, including the minus sign, and multiply by each thing inside. Okay, this is done in one of maybe 1.3 or something. It's very important to remember, and it's frequently forgotten. So let's take so this equal to the denominator is here. I will skip writing it. Okay, this stuff. This 6 times x, okay, remember each thing on the outside will multiply with everything on the inside one time. So 6 times x is 6x. 6 times negative 2 is minus 12, okay? And you multiply by including a sign. And then we'll take this as its own sign. The minus sign turns into a negative. We'll take it as a negative sign. So minus 2 times x is minus 2x. And then minus 2 plus times positive 2 is minus 4. And that's how we get here. And then at this point, then we can do 6x minus 2x. That is 4x. Okay? And then minus 12, and then minus 4 again. That's minus 16. And that's how we got the answer here. Is the answer then is 4x minus 16 is right here, see, is over the denominator, that stuff, right? And that is your answer. However, but once we get to 4x minus 16, we notice there's a common factor there. We might as well take that out to make things look a little neater. And so then we pull out the 4, and that becomes 4 times x minus 4. And that's how we get to the right answer. So this is example 5. Please do it as part of your homework. Now, normally, if you get somewhere and you see a very obvious factoring, like 4x minus 16, then you just naturally take out the 4. Okay, no reason. That's just what everybody does. Okay, and we will do what everybody does. So next, let's look at example 6. Now, example 6, we have an even more complicated looking fraction. So let me clean off the board. So now let's look at example 6 on page 73, where you get this complicated looking thing, okay? Things are looking complicated, but nothing's different because we have something, you're dividing by a fraction. To divide by a fraction, as always, how do you divide by a fraction? And you invert and multiply by that fraction that you're dividing by, okay? So let's invert and multiply this thing right here, and that's the principle we are going to apply. So that equals to, we'll write down the numerator. In this case, y over 1 plus x. We'll ignore it for the moment and just copy it down. Okay, we'll invert and multiply this thing, which is y over x. All right, so far so good. And then we are going to, the standard practice is we will turn this whole thing into a fraction. Like, that is, y has nothing on the denominator. That means its denominator is 1. So then we will put this into a common factor like this thing. Or we'll add it together like this, okay? With this principle, and which the formula says here, Okay, and then so we'll do that. That will be equal to making this into a common factor. That will be x. Okay, and then this will have to be multiplied by y times x, because together it cancels out to be y, right? If you break it into two fractions. And then over here, nothing's happening, so we will just put it as 1. So this is equal to 1 over x over, and then this will be just y, if you were to take the fraction apart into 2 again. Okay, so this thing will be multiplied by y over x. That comes from our inverting this thing. Okay, to divide by a fraction is to invert and multiply. So we inverted that, we got here, and then what? And then nothing. Okay, this will be simply be equal to, you just, well, this becomes x squared, and and then that is just y times xy xy plus 1, and that's that, right? Okay, so far so good, and that is our answer. See, as you can see the bottom. Right, now what is, anyway, so that's the answer to our problem. Now let's do something else, okay? Now please do this as part of your homework and what I'm about to do next. Let's make up a different problem. Let's say our problem now is x over y divided by y plus 1 over x. Okay, that's our problem. Okay, I just made up a new problem. Well, how are you going to do that? Well, as always, to divide by a fraction, you invert and multiply. But that isn't even a fraction. Now what? Okay, we need to make it into a fraction. So what we're going to do is, what is that? We have just calculated that that thing is this fraction. Okay, so what you do is you pull this out into a common denominator, that is, pull this trick, right, which becomes that. So then we do exactly what we did there and turn this into a fraction, because this is just stuff added to a fraction. It's not a fraction itself. So we turn it into a fraction, and x over y, okay, divided by, copy that down, and we just did it. So that will be, so this thing is the same as yx plus 1 over x. Okay, now it is a fraction, okay? Even though there's an addition inside, it's still a fraction. It's a true fraction, right? There's a fraction line going across the whole thing, whereas that isn't a fraction. It's just a fraction plus some other thing, which make it, the whole thing is not a fraction anymore. But this is, okay? This whole thing is a fraction. And once you're dividing by a fraction, then you apply the invert and multiply principle. So this equals to x over y times invert and multiply that thing. It will be x squared, x over y, invert this thing, which is x over yx plus 1, okay? And that equals to, where's my equal sign? I'm missing it there. And then it equals to x squared times y times yx plus 1, okay? As you notice, this is just this thing flipped over, right? Well, that makes sense, because I just took this thing and flipped it over, so the answer also flipped over. Otherwise, it's the same. See, same except flipped over. So that is how you do fractions, rational expressions, where there's some plus sign on the bottom. Okay, in general, when you have a big long division line and with complications on top and complications on the bottom, what you do is you turn each thing into a fraction. Okay, for example, let's say what if I were to put plus 1 here? Then you have two things. None of them are exactly fractions. You can turn this one into a fraction the same way you turn this thing into a fraction, and then do the invert and multiply and then fix the whole thing up. Okay, so that's how you would do it. In general, that is the principle that we live by in this rational expressions section, is anytime you do a rational expression, you invert and multiply. To divide by something is to invert and multiply that thing that you're dividing by, okay, the denominator, or the thing, whatever you're dividing by. Okay, see, a over b divided by c over d, you invert c over d, the thing you're dividing by, and then you multiply everything together and it'll come out nicely. Well, not always nicely, but at least it'll come out. Okay, you might get quite a mess sometimes, and that's to be expected. So, but anyway, that's example 6, and please do that as your homework. And with that, we have come to the end of this section. Right, so this section is completely dependent on you knowing how to do factoring and knowing all the algebraic rules that you learned in pre-algebra, all this stuff, and very specifically how to add fractions, okay, and how to divide by fractions. The division line, the big long division line looks confusing because there's more division lines here, so you got lots of division lines, but all that means is that the big long division line stands for divide. That is, everything before is going to divide by whatever's after. And that's how this stuff works. Okay, and everything goes by principle, and you follow the rules exactly until you get to the right answer. So for homework, please do the problems that I showed you earlier in the beginning of the screen. And with that, that should come to the, that should be the end of this section. Now, if you have trouble with this section and the homework that I assigned isn't quite enough, please feel free to do a few more of the odd problems, because all the odd problems, you have their answers at the back of the book where you can check to see if you got it right and redo it if you get something wrong. Most of the time it's probably just you just made a slight mistake, but if anything you don't understand, please redo the examples, okay? Or even pull out the pre-algebra book and see where it gives more detailed explanations on how this stuff is done. Yeah, I don't have the pre-algebra book for download right now, I don't think, and I should probably do that. I think I might do that. But anyway, you can load the pre-algebra book yourself. Pre-algebra is a prerequisite in this course, what matters is that you don't have to know everything that's ever mentioned in pre-algebra. Just this particular chapter, everything in this particular chapter is extremely important, okay? That is not true necessarily true for the rest of the algebra, okay? I don't mean you have to memorize everything to make it through this course, but in but how to do every single problem in this first chapter is critical. Okay, it makes the difference of whether you enjoy algebra or you just struggle through and not have a clue what's going on. And why you're struggling through? Because you don't know how to divide by a fraction. That's why. Or you don't know how to make something into a common denominator. That sort of thing, okay? Because that will show up time and again in basically every chapter, everything you ever do in math from this point on. This type of thing will show up. So it's extremely important for you to be extremely good at it, okay? To know it like the back of your hand. And to do that, the best way is to do more practices until you do get a good solid hang of this stuff.